Hello students, so I welcome all of you to my another video. So today we are going to discuss about the triangle law of vector addition. That means how to add two vectors using the triangle law. Now those who are seeing this video, I hope you have a very basic idea about what are vectors. Now what are vectors? Now, vectors are certain physical quantities which have magnitude as well as direction. Now the opposite of vectors are scalar quantities. Now what are scalar quantities? Scalar quantities only have magnitude and vectors have magnitude as well as direction. For example, I will give you a slight hint about what are scalars and vector quantities. If I say that I am walking 5 meters, so this is a scalar quantity. Because over here you see 5 meter denotes only the magnitude. Okay. Now if I say I am walking 5 meters towards east, then this becomes a vector quantity. Well, now why it becomes a vector quantity? Because you see this is the magnitude and this one denotes the direction. So vector quantities have magnitude as well as direction. Now there is one more extremely important difference between scalars and vector quantities. Scalar quantities can be added algebraically, okay? But vector quantities are those quantities which cannot be added algebraically. To add two vector quantities, we need to use specific rules, like for example the rule that we are going to discuss today, that is the triangle law of vector addition. Now I will give you a small example of this one. Suppose if I say that 5 meter per second plus 2 meter per second. Now all of you can understand that these two are scalar quantities. This is one speed, this is another speed. So 5 meter per second plus 2 meter per second. So what will be the answer? That will be 7 meter per second. So this you are adding over here algebraically. So 5 plus 2 gives you 7 meter per second. But if I tell you that a boy is running 5 meter per second towards east. Now with this you have to add 2 meter per second towards north. Now can you tell me what is going to be the answer? So some of you will tell me that the answer will be 5 plus 2, that is 7 meter per second. But what about the direction? What about the direction? Okay, so east north. So some of you will tell me that the direction is northeast. But students, this is entirely wrong. Okay, so this is entirely wrong, because over here you see we are adding 5 and 2 algebraically, but this entire thing is a vector quantity. So vector quantity cannot be added algebraically. So if you add these two quantities, you will never get 7 meter per second. Okay, so if you add these two, you are never going to get 7 meter per second, because over here you are adding algebraically and vector quantities cannot be added algebraically. So vector quantities have to be added using certain rules. So today we are going to discuss about that one particular rule, that is triangle rule of vector addition. There are many rules. So we will be discussing about the triangle rule of vector addition, then we will be discussing about the parallelogram rule of vector addition. So today we are going to discuss about this triangle. So I hope all of you can understand why vector quantities cannot be added algebraically. They have to be added using certain vector rules. Okay. Now what is this triangle rule of vector addition? So let us first see the statement. What does this triangle rule of vector addition says us? It says if two vectors are represented by, or you can say if two vectors are represented in magnitude and direction. So if two vectors are represented in magnitude and direction by the two sides of a triangle, taken in the same order. This is very important to understand. Taken in the same order, then their resultant is represented by the closing side of the triangle taken in the opposite order. Okay, now let's see what does it mean. So over here, these two phrases are very important: same order and opposite order. Okay, so it says that if two vectors are represented by the two sides of a triangle taken in the same order, then the resultant, that means, now what is the meaning of resultant? So if you add two vectors, the result that you will get, that is known as a resultant. So the resultant will be the closing side of the triangle taken in the opposite order. Now what does it mean? You see, suppose we have one vector over here. So this is one vector. This point is O, this point is P. Okay, now you are given to add two vectors. Okay, one of the vector is OP. This is one vector. Suppose this one is vector A. This is vector A. Okay, and you are given another vector. Suppose vector B. Now, if you are representing these two vectors as the two sides of a triangle, suppose these two are the two sides of a triangle. Okay, so this is one vector, and this one is suppose PQ. It is another vector. Suppose this is vector B. Okay, so these two are the two sides of a triangle taken in the same order. Now, what is the meaning of same order? You see, this vector I have drawn from, I have started this vector from point O and the vector ends at point B. Now, the point where the first vector ends, from there only I have drawn the second vector. So, this becomes same order. If I had drawn in this way, then this will become opposite order. Okay, but I have drawn the two vectors in this way. So it means it is going in the same direction. You see, it is going in the same direction, same way. So this means that the vectors are going in the same order. In many books, you will find the rules to be written as head to head or head to tail. It can be anything. You can understand in any way that you like. So see, the point where the first vector ends, over there only the second vector starts. This means the two vectors I have taken in the same order. Okay. So these two vectors I have represented by the two sides of a triangle. Now these two vectors I have to add. Now what will be the resultant? What will be the resultant is, if you add two vectors, what is the magnitude of the result that we are going to get? So the triangle rule states that if two vectors are represented by the two sides of a triangle, if we have taken in the same order, then the resultant will be the closing side of the triangle. Okay, so resultant will be the closing side of the triangle, but taken in the opposite order. Opposite order means in this way. Suppose this is R vector. Okay, now what is the meaning of this opposite order? See, this one I have taken vector A, this one I have taken as vector B. If I had drawn this vector R in this way, then all the three vectors would have been in the same order. But the triangle rule states that if two vectors, the two vectors which we are given to add, if these two vectors we have taken in the same order, then the resultant will be in the opposite order. This will be the resultant. Okay, this is going to be the resultant. Now here we are going to add these two vectors. Now let us assume that the angle between the two vectors is theta. Now, why we have taken the angle between the two vectors? Very important. Why we have taken the angle between the two vectors? Because you see, when we are going to add two vector quantities, suppose this is A vector, this is B vector. So when we are going to add two vector quantities, at that time, vector plus vector will always give you a vector quantity. That means this is a R vector. So this is a vector quantity, and vector quantity always has a magnitude and a direction. Okay, remember the example that I gave you, 5 meter per second towards east. If I say 5 meter per second towards east, plus if I tell you 2 meter per second towards north, if these two I tell you to add, Okay, so first of all, the answer that you will get, that answer has to be a vector quantity. That means there has to be a magnitude as well as there has to be a direction. Now, if you are thinking that the magnitude will be 5 plus 2, that is 7, then you are completely wrong. Why? Because I told you that vector quantities cannot be added algebraically. So 5 plus 2 you cannot add algebraically and you can get 7. It cannot be done. You have to add these two vectors using certain rules. So whatever may be the value, suppose I am telling x meter per second. So this magnitude we are going to find out first. What is the magnitude of the resultant and how to add? Also, towards east and towards north, this particular resultant velocity will have a particular direction. Okay, this one will have a particular direction. So the direction also we can get from the triangle law. That is, the resultant is acting in which direction. Fine. So that is why the angle between the two vectors is very important, because you see the magnitude that you are going to get, it all depends upon the angle between the two vectors, how the two vectors are inclined to each other. Fine. That is this one, this angle theta. So how the two vectors are inclined to each other, on that the magnitude of this r vector is going to depend. Okay. Now how we are going to find out the magnitude of this r vector? You see, if this is a triangle, the triangle law states that if this one is vector A, this one is vector B. Okay. Now this has a particular magnitude, so maybe 5 centimeter. This one also has a particular magnitude, maybe 7 centimeter. So the triangles, this magnitude, this length, okay, this length will give you the resultant, the magnitude of the resultant. Okay. Suppose if I say this is 5 meter and this is suppose 2 meter. So whatever will be the magnitude of this length, okay, whatever will be the magnitude of this length will be the magnitude of the resultant vector. Okay, so our first task is to find out the magnitude of this length. Now all of you can understand why I am saying repeatedly that this particular magnitude is going to depend on the angle between the two vectors. You see, if I just change the angle, okay, if I just change the angle over here, then this magnitude is also going to change. Okay, so the magnitude of this particular length of this particular vector is going to depend on the angle between the two vectors. That is why this angle is very important. So first we are going to find out what will be the length of this one. What will be the length of OQ? Okay. Fine. Now suppose I am considering that this is vector A, this is vector B. Suppose the magnitude of this one, is A. Okay, that means the magnitude of vector A, here I am writing. Suppose the magnitude of vector A is A and the magnitude of vector B is B, right? And the magnitude of vector R is R. So first we are going to work with only the magnitude. Remember, when you are adding two vectors, over here in triangle law of vector addition, when you are adding two vectors, you cannot find the magnitude and direction simultaneously together. Okay, you have to find out one by one. So first we are going to find out the magnitude. Okay. So to find out the magnitude, that means the length of this OQ, first let us draw a perpendicular. This is a perpendicular surface. Okay, E. This one is a perpendicular. Fine, E. So first we have drawn a perpendicular. Okay. Now see, we are going to find out, remember what we are going to find. Always students, while deriving anything, first remember what you are going to find out. Okay, first remember what you are trying to find out. Don't just work out blindly. Okay, first you have to understand what you are trying to find out. So we are trying to find out the length of this one. Now of course, if you take only this triangle, this is not a right angle triangle. So you cannot use Pythagoras theorem over here. So you have to create a right angle triangle. That's why we have drawn a perpendicular. Also remember why we are doing certain things. Okay, while deriving anything, please remember why we are doing certain things. Now suddenly if you are thinking that why we have drawn a perpendicular over here, so the answer is we have drawn a perpendicular over here because to make this one a right angle triangle, so that we can use Pythagoras theorem. Okay, if we have only this triangle, then we cannot use Pythagoras theorem over here. Okay, so let us first take the triangle. In triangle OEQ, okay, this triangle OEQ, this triangle we are taking. Okay, so let us find out OQ square. OQ square. Remember, now we are only working with the magnitude, that is the length. Only we are working with the magnitude. So our task is to find out OQ. Remember, what is our task? Our task is to find out OQ. Okay. So OQ square is going to be, use Pythagoras theorem, that is QE square plus OE square. Okay. QE square plus OE square. Now see, OE square can be written as, what is OE? I can write OP plus P whole square. Okay, if you break this term, we get QE square plus OP square plus P square plus 2OP into P. Okay, this is the term that we are going to get, and let it be equation 1. Now, if you are thinking that we have already taken out OQ square, now just go and do the square root and find out OQ, but just wait a minute, you see. What is QE? What are the terms that we have over here? What is QE? We don't know what is QE. This QE we have drawn, so we don't know the length of QE. Okay. Then you see OP. OP we know. The length of OP is how much? A. The magnitude of A. P. What is P? Also we don't know the length of P. Okay. And over here we have OP, which we know, and P. P also we don't know. So we cannot use this one. So we have to replace these terms. Okay. Now let us take this small triangle. In triangle QPE, this triangle. From here you see I can write PQ square, again by Pythagoras theorem, PQ square equals to QE square plus PE square. This one I can write. Okay. So PQ square will be equals to PE square plus QE square. Right? Now from here let us find out QE square. QE square will be PQ square minus PE square. So let this one be equation 2. Okay. Now just what I will do, I will put this equation 2 in equation 1. And in place of, here see we have got one QE square. So in place of this QE square I will put this one. So putting equation 2 in 1. Putting equation 2 in 1. So you will get OQ square equals to PQ square minus PE square, that is equals to QE square. Okay. Plus we have OP square plus PE square plus 2OP into P. So PE square will get cancelled. We are left with PQ square plus OP square plus 2OP into P. This is our OQ square. Okay. So let it be equation 3. Now see, still now our task is not done. Why you see? We have PQ. PQ, we know the magnitude of PQ, that is B. Magnitude of PQ is B. Then OP, we also know the magnitude of OP, that is A. Over here also there is OP, but over here one more term is there, that is PE. We don't know still the magnitude of PE. So we have to find out this PE and then we are going to replace this PE. Okay. To find out this PE, again let us take this triangle. In the triangle QP, this triangle QP, let us find out cos theta. Okay, cos theta. Okay. Now some of you might wonder why we are taking cos theta, why we are not taking sin theta or tan theta. Because students, you see, we have to find out this PE. Okay, we have to find out this PE, and we know this PQ. So see, PE is the base and this PQ is the hypotenuse. So what is the function between base and hypotenuse? It is cos theta. So that's why we are taking cos theta. Always know the reason why you are doing certain, you are using certain things. So cos theta is equals to base by hypotenuse. That is PE divided by PQ. From here you will get PE equals to PQ cos theta. Okay. So let this be equation 4. Now just put equation 4 in equation 3. Putting 4 in 3. So just put equation 4 in equation 3. See what you will get. OQ square equals to PQ square plus OP square plus 2OP. dot P. So P is PQ cos theta. PQ cos theta. Okay. Now, this expression that we are getting, you see, we know all the terms of this expression. OQ also you know. What is OQ? It is the magnitude of R. PQ is B. OP is A. Okay, and here we have OP and PQ and cos theta. Theta is the angle between the two vectors. Remember this one. Okay. So over here you can write OQ is basically the R. Okay, OQ is basically the magnitude of R. PQ is basically the magnitude of B. OP is basically the magnitude of A. Okay, so all these things if we put over here, we get R square equals to A square. This OP I am writing as A square, okay, plus PQ square, that is B square, plus 2AB cos theta. Okay, so from here you will get R will be equals to A square plus B square plus 2AB cos theta square root. This will be the magnitude of R. Okay, this is going to be the magnitude of R, right? So you see one more thing. What is theta? Theta is the angle between A and B. Angle between vector A and vector B. So theta is the angle between vector A and vector B. Now see one more thing. As I told you earlier, the magnitude of R will depend on the angle between the vector A and vector B. You see, if theta changes, then R is also going to change, though A and B are same. Okay, so if we take two vectors like this, if this is one vector, if this is another vector, okay, now these two vectors, so the point where the first vector ends, from there only the second vector, if it starts, then we are going to say that these two are acting in the same order. So the resultant vector will be in the opposite order. So this will be the resultant vector. Of course, the resultant vector's magnitude, this particular length, is going to depend on the angle between the two vectors. Okay, this is going to depend on the angle between the two vectors. I have taken same magnitudes for A and B, but the angle I have changed. So the resultant's magnitude is also going to change. Fine. Okay. So this is vector R. Now one more thing that we have to do is, since R is a vector quantity, since this resultant is a vector quantity, as I told you, this is the magnitude. Okay, this is the magnitude of R. Magnitude of R vector. Magnitude of R vector. Now, any vector quantity has magnitude as well as direction. Direction is also very important. We know the direction of vector A is in this direction. Direction of vector B is in this direction. But what is the direction of this resultant vector? Okay, for that we are going to take this angle to be alpha. Suppose the resultant makes an angle alpha with vector A. You can take this angle to be alpha as well, no problem. With any vector you can take the angle. Okay, with any vector you can take the angle. The answer is going to change, but overall the thing is going to be correct. So this angle, suppose vector R makes an angle alpha, okay, with vector A. Now how to find out this alpha? We are going to find out the angle which the resultant vector makes. So here, how to find out the angle of the resultant vector. So angle of the resultant vector. So we are going to find out alpha over here. Now let us take tan alpha. Tan alpha. Okay. Now what is tan alpha? What will be tan alpha from this triangle? So tan alpha is perpendicular divided by base. So QE base is our OE. This is our base. Okay. Now what is OE? So QE divided by OE is OP plus P. OP plus P. Let this be equation 1. Now see, QE, we don't know what is QE. Okay. OP we know. What is OP? The magnitude of A. PE also we don't know. Okay. So we don't know QE, we don't know P. Fine? Okay. Let us take this small triangle. So in the triangle QPE, first you find out sine theta. Sine theta. So sine theta is perpendicular divided by hypotenuse. So QE divided by hypotenuse. Hypotenuse is PQ. Okay. So QE will be equals to PQ sine theta. This is your QE. Let this be equation 2. Now why we have taken sine theta? If you ask why we have taken sine theta, because first you have to find out QE. QE is, you see, QE is a perpendicular. And which variable do we know? Which side do we know? We know this hypotenuse. This one we can use. So perpendicular we have to find out, hypotenuse we know. Perpendicular hypotenuse, which function? Sine. That's how we have taken sine theta. Now see, also we have to find PE. Now I hope you can answer which function. Now why I am telling all this, why I am going into the details, because while deriving, in case you forget what are the steps that you have to do, just remember what you must do, what are the things that you have to find out, okay, and to find out that one, what are the steps that you have to take. No need to just mug up or learn through the derivation like this. Just understand each and every step what you are doing. So see, over here you have to find out P. So P is the base and we know the hypotenuse. So which function we are going to use? Cos theta. So cos theta will be equals to base divided by the hypotenuse PQ. Okay. From here PE will be PQ cos theta. Let this be equation 3. Fine. Now put this equation 2 and equation 3 in equation 1. So putting 2 and 3 in 1. Okay. So you will get tan alpha will be equals to QE. What is QE? PQ sin theta divided by OP plus PE is PQ cos theta. Okay. Now we can put down the magnitudes. So what is PQ? PQ, what is PQ? PQ is B, the magnitude of B. So B sin theta divided by OP. What is OP? OP is A. So A plus B cos theta. So this is your tan alpha. Okay. And once you know tan alpha, you can easily find out alpha. Those who know inverse trigonometric function, I hope you can understand. This is tan inverse B sin theta divided by A plus B cos theta. Okay. Now, if you are wondering how to understand which is A, which is B, okay, remember the resultant, the angle with which vector you have taken the angle, that means the resultant is making a certain angle with a particular vector. The vector which you have taken over here, that means the resultant, suppose it is making an angle alpha with vector A. If that angle you have taken alpha, then that vector will become vector A and the other vector is going to become vector B in this particular formula. Okay, so in case if you don't understand which is A, which is B, suppose, because every time it will not be given as A and B, it can be given in any other alphabets. Okay, so for this formula, which one to understand which is A, which is B? Okay, remember which is A, which is A. A is the vector with which you have taken the resultant, the angle of the resultant, that is A. Okay, and the other vector is B. The vector with which you have taken the angle of the resultant, that particular vector is A. Fine. Suppose this vector, if I tell that this vector is suppose vector T and this vector is suppose vector B. Suppose, then in place of, so this angle I have taken is vector T. So in place of A, I will give T. Okay, and in place of B, I am going to give D. So remember which vector how to put. The resultant makes an angle with a certain vector, that vector will become vector A and the other vector is going to become vector D. Vector B, sorry. So this is your angle. Okay, so once you know the magnitude of this r, you can find out the angle. Both cannot be calculated together. Okay, in this particular law, triangular, you cannot calculate both of them together. You have to calculate one by one. Once you have calculated the magnitude, then you can calculate alpha. Suppose alpha is 30 degrees. Suppose I am saying, suppose alpha becomes 30 degrees. So you can say that the resultant makes an angle 30 degree with vector A. Okay, so this will be the answer. Suppose the resultant is coming 5 meter per second. So you can say the resultant is 5 meter per second making an angle 30 degree with vector A, and that will become your answer. So that is the way how you can add two vectors using the triangle law. This is also known as the analytical method. Remember, analytical method. Now what is the meaning of analytical method? Analytical method means mathematically. Okay, we are deriving this one mathematically. That is the analytical method of vector addition. So using the triangle law. So that's all for today's video. If you like the video, please like and subscribe. Thank you.